Welcome to our new unit, electricity and magnetism. This will be the most practical unit that we do the whole year. As future homeowners, you're going to want to know how to do electricity so you don't have to call your electrician or your father to do it for you, or even worse, your father-in-law to take care of the job that you or your spouse never learned how to do. Okay, so electricity and magnetism. Here, let me just back up this Bible verse. This is what we've been doing all year. Stop and consider God's wonders. Do you know how God controls the clouds and makes his lightning flash? That's what we do. Every block, we come together and we stop and we consider all the wonders. That's what we've been doing the whole year. And this unit in particular, we're going to look at how the clouds happen and the lightning flashes. We will learn how that works and the machinery behind it. And it starts with magnetism and electricity joined together. Now, in the previous unit, we saw the electromagnetic spectrum. Electricity, magnetism. Electricity and magnetism are cousins. They're cousins. They work together. When you marry these, no, that doesn't sound right. When these cousins are together, that's light. Electricity, electric fields and magnetic fields, that's light. But we're going to split them apart now and just have electricity and just have magnetism, but they're still going to work together. They're still going to come together for their family reunions. And we're going to start with magnetism first. Now, you remember magnetism when you were a kid and your preschool teacher handed you magnets and all those sorts of things. You know that a magnet will attract and have a reach. It can reach and grab onto things. That was always what was so cool about magnets. And we called the ends of the magnets. Magnets always have how many ends? 2 ends, correct. And those 2 ends are called poles. Poles. And then we label it like our planet in the North Pole and the South Pole. So magnets have 2 ends. You can't have a magnet with just 1 end. And you can't have a magnet with 3 ends. It's 2 ends, a North and a South Pole. Which is going to be kind of related to a battery. I mean, think about a battery. How many ends, how many sides does a battery have? That's 2. That's the plus and the minus. So there's a relationship that you're going to see between magnetism and electricity. There's 2 ends to it. All right. So we have the poles, and we know that opposites attract. Pluses and minuses attract. So here we have a plus and a minus, and they're sticking together. But here we have a plus and a plus. Like charges repel. We remember that, and that goes back to understanding the atom. You remember when we learned about protons? You get a lot of protons together, they hate each other. They're going to want to fly away and travel away from each other however they can. And they don't want to be trapped together. They want to leave, spread out. And the same with electrons. They want to spread out across the atom. They don't like being near each other, so they spread out. But electrons and protons attract each other, and that's why the atom assembles itself, is because the electrons travel to the protons and hang out. Let's show you this. I need my balloon of science here. Balloon. All right, this balloon, you know about static electricity, right? You charge up your hair, then, you know, the balloon sticks to things, and so does your head. Just kidding. All right, so we have the balloon here, and let me turn on the lights for this. I'll take it out of here, but in a second so you see better. Let me turn it this way. See now, watch. Let's make sure science works before I come closer to you. All right, I'm going to take this. Now, what I have here, I don't need the jar, the flask. This is metal with a metal rod connected to metal hooks, connected to metal pieces of foil. So metal, 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 metal. That's all it is metal. There's no magic going on here. Just metal. Now, I am putting negative charge all over the balloon. I'm taking it off my hair, putting it on the balloon. Now, as I bring this negative charge over, watch what happens to the fins. Ooh, they stick out. Whoa. Wow. Now what? I didn't even have to touch it. The electrons on the balloon took the electrons on the flask here. Well, I took the flask off, but the metal, and those the electrons here ran away. Where could they run? They can't run through me because I'm touching plastic. They don't like to run through plastic. They ran down the metal to here. So half, they didn't all run to this one. They all ran to this one. They'd be like, why are we all together? I hate you. And they all ran to that one. They said, why are we all here together? So half ran to this one, and the other, you go over there. We'll split up. So half goes here, half goes there. This half still doesn't like this half, so they spread out. They said, well, we can at least spread out. And they spread out. Now, once I withdraw the balloon, especially if I discharge it, once I take the balloon away, all those electrons down here can say, the balloon's gone. So there's nothing pushing us down here. Let's run back up and spread out again. They spread out, and then everything can return to normal. All right. So spreads out. They all run away from the balloon, and now they can all run back to their original locations when I pull the balloon away. So charges attract and repel and all that. We'll come back to this balloon later when we electrocute it with a Van de Graaff generator. All right. Now, oh, yeah, this is pretty neat. Watch this. Fun little trick. Oh, slippery balloon. Watch the water. Look at that. You see the water move? The water has a charge too. Remember, water's polar molecule? It's wiggling. Look at that. How neat is that? Let's talk about magnets. Why does my hair stand on end? Because my hair is all the same charge. This hair, that hair, that hair, that hair. They don't want to lie on flat on top of each other because it's all the same charge. Same charge repels. So they all moved. They all tried to spread out. They didn't. It's not like the electricity tried to stand up. It just pushed on the other hair and pushed off, and then it went to the other hair and it says, I don't want to go that way either. And so they all have to stand alone and separately. Okay. The proton is positive, the electron is negative. Remember, if you lose the negatives, you lose the electrons. You lose the negatives, you become positive. Remember all that stuff from previous? Let's talk about these magnetic fields. So magnets have this reach. This reach is a magnetic field. You know about force fields in your space movies. Well, there's things called magnetic fields and electric fields. And so we're going to look at those fields here. They travel from one pole to another pole, from the north to the south. I'm going to show you some here. All right, let me darken the screen here. And we'll look at the overhead projector here. I have two magnets here. You can see the color this way, and that's good. The blue side and the red side, I think it shows up. You can kind of see it there. I'm going to put a piece of plastic on. Actually, let's just do one magnet. These are the boxes they came in. I'm just going to put those there and there. All right. This is ground up metal. It's like I put my file cabinet through a paper shredder. All right. It's just ground up metal. Nothing fancy. All right. I'm going to shake some on here. Let's watch what happens. See that? Maybe? Let me get a little closer. Maybe I should put you on the projector. Tammy. I think that's fine. It's forming a pattern. Look, it's reaching from one end of the magnet to the other, from the red end of the side to the blue side, and the blue side to the red side. It's traveling. All right. And the fields are strongest. The ones that are closer are stronger than the ones that they get weaker as they travel out. Now also know that the field lines aren't two-dimensional. They come up off the page. So there are field lines that we don't see, that we're not seeing in this demonstration, that come up off and down into the projector. So these are 3D field lines, even though we're only seeing the ones lying flat on here. Now, I used the plastic here. Can you appreciate why I used the plastic? If I didn't use, these are like ink blots. What do you see? I see my mom telling me I'm never going to be good enough, and my dad saying that I'm not good at baseball. And but here, I'm going to take this, I'm going to dump this back into the bottle, and I'm going to now do two magnets. All right, now this one, I'm going to have the red. This is red. Can you see that in the camera? And that's blue. If I see, they like each other, right? Okay. Now, this one is going to look like, I think this one looks like E.T. Maybe you guys say Baby Yoda these days. All right, so I'm gonna go a little bit here. See that? All right, so you're seeing some field lines. There. Some field lines there on that magnet. But what about between the two magnets? What's gonna happen? Oh, they're attracted to each other. Maybe it's a koala bear. Maybe it's a koala bear. See the koala bear? He needs a mouth. All right. Some eyebrows. All right. So the field lines are not just between this magnet, that relationship, it's also this relationship, but also the relationship between these two magnets. So we got 3 sets of field lines. 1, 2, 3. All right, now let's redo that. Here, another ink blot. Okay, what do you see now? Okay, let's this time make the two magnets repel each other, and I'll do it again. So I'm going to turn it this way. Now they repel you, right? Whoa, I don't like you. Okay, so this time, okay, starts off the same. This one's going to look like an owl. Don't believe me? All right. So that this magnet still likes, the other pole of that one, and this one same way. But what about in between the two? They don't reach to each other anymore.
They're just going straight up.
They're going straight up. It's going to make a kind of like a beak. Maybe sometimes it's more beaky than others. I don't know. There. Oh, there it is. Now I got a beak. The plastic just had to bend. In fact, some of it, if you were looking from the side, you'd see that it's climbing up. It so much doesn't want to go sideways. It'd rather fight gravity and travel up and back on those field lines and go that way. So magnets have field lines. That's pretty neat. Okay. Let's get back to magnets. Now it's not just magnets that have magnetic field lines.